This video is on direct variation, and we're just going to take a look at a definition and then an example involving it. For direct variation, you might hear something using these words: the variable y, and I'll say is directly proportional to, right? So is directly proportional x. So when you say directly proportional to, sometimes you might hear that said as varies directly, right? Or varies directly as. So the variable y is directly proportional to x, or y varies directly as x. If there is a positive constant m such that y equals mx. Now, we used y and x here. We used m as that positive constant. That constant of variation is something we call it. But keeping in mind that, this is y equals mx, this would be like the equation of a line, right? M would be the slope. But it doesn't have to use these variables, right? I chose them this way because it's the way you'll see it in the textbook we're using. But really, the variables could be any variables. Those are just ones I picked. So if we're looking at an example, I'll say the weight of a shark is directly proportional to the length of the shark. A 1,900-pound shark is 12 feet long. Right, so just information given. I haven't really asked a question yet, right? So typically the first thing you'll be asked to do is to find an equation of variation for the weight of a shark. So first off, what we should notice is that we're telling us the weight of the shark is directly proportional to, right, the length of the shark. That's similar to what we said in our definition above, right? The variable y is directly proportional to x, means I write it so there's some positive constant m such that y equals that constant times x. So think about what y and x would be in terms of this example. So the first thing we talk about says the weight of a shark is directly proportional. Well, that's the same as saying the variable y. So the weight of a shark, I'm going to use a variable for that. And I'm going to call it, I'll use w just for weight. You could call it y like we did above. So I'll say w is equal to, and then we say directly proportional is telling you where to put the constant, right? That's like where our m went, right? So y was equal to m times x. Here, this directly proportional to the constant. I'll call it m like we did before. You call it anything you want as long as you're not using the same variables you had before. So w equals m times, and then the weight of the shark is directly proportional to the length. When y was directly proportional to x, we said y equals mx. When the weight is directly proportional to the length, maybe I'll call the length here L. So w equals m times L. So this gives us a general equation, right? But we want to look, to figure out what m is. So they gave us this kind of, initial condition here. They gave us a condition that we know. It says a 1,900-pound shark is 12 feet long. So we're going to use the info given to solve for m. So when we do this, so what we did here, I think I lost it on the video, is I said we're going to sub in for the weight, 1900, all right, and then m stays m, and then L is 12, right? We're using the specific condition we know. And we divide both sides by 12, and that's how we got to this 158.3 is equal to m. Now remember, that's pounds per foot because the units of the 1900 over the units of the 12. Once you have that, all right, now we know what m is, we can sub m back into the original formula, and we leave w and L as they are. So we get w equals 158.3 times L. And this is going to be the equation that gives the weight of a shark based on the length. For any length I put in, I could find the weight. For any weight I put in, I could find the length, now that I know what that constant of variation is. Let's take a look at just using this. All right, so if I was to look at find the weight of a shark, that is 14 feet long. Well, to do that, we're just going to use the equation we found. The W equals 158.3 L. And what do we know? We know 14 feet long is L. So we're going to substitute in. We have W equals 158.3 times L, which is 14. And if you multiply those together, you should get 2,216.2 pounds. So we're using this equation to help us estimate the value of a shark that's 14 feet long. Now remember, this doesn't necessarily come out exact, right? This is, you know, what it should be theoretically. In real life, you know, it doesn't necessarily come out exactly to this, but it gives us a model to use, right, to determine the weight or the length. Yeah, we'll just look at one more. Find the length of a 1,775 pound shark. Again, we're using our formula, right? The formula was the weight is equal to 158.3 L. And the part they gave us this time was the weight, right? They gave us the weight. We're trying to find L. We're trying to find the length. So we're going to substitute in 1775 equals 158.3 times L. And then we're just going to divide. So I'm going to divide by 158.3 to isolate L. Divide by 158.3. I end up with L equals, this comes out to 11.2 to the nearest tenth. We're talking about what here? Length. So we need the units, which in this case were feet, because the original units were in feet. So hopefully this helps you set up direct variation problems. They're not overly challenging. They all follow the same type of formula. The key thing I would say in setting up is notice, you know, where it says is directly proportional to. That's telling you, you know, that's where the equation splits, right? So we had the weight was equal to m times, and then whatever the other variable is. Use a specific condition to find m, and then you can come up with a general equation that you can use to actually, you know, model the data for any length or any weight in this case.